What China discovered on the dark side of the moon could change the fate of all humanity. An inexhaustible energy source, underground cities, and trillions of dollars in resources. All of this is already in the hands of a single country, while the entire world is debating whether it's better to go to Mars or focus on Earth's problems. One country is quietly and methodically taking control of the most valuable object in our solar system. And this isn't some distant planet, it's our moon. China has become the owner of the dark side of the moon before our eyes, and this means that the balance of power in the world could completely shift within 10 to 15 years. For a long time after the Apollo and Luna programs of the 1970s, humanity seemed to have lost interest in our planet's moon. Everyone looked further afield, to Mars, the moons of Jupiter, and the outer planets. The moon, already explored, seemed boring, a relic of the past. But while everyone else was dreaming of distant worlds, China was making a very different calculation. In the early 2000s, Chinese scientists and engineers conducted a sober analysis. What would it take to achieve technological progress? Where can the resources needed for energy independence be found? And how can they stay one step ahead of their still dreaming competitors? The answer was simple and brilliant: the moon. Not Mars, which is at least a 9-month flight away, not asteroids, which are almost impossible to reach, but our good old moon, which is only a 3-day flight away. And in 2007, China launched the first spacecraft of the Chang'e program, named after the moon goddess from Chinese mythology. But it wasn't about romance, it was about cold calculation. Chang'e 1 created highly detailed maps of the lunar surface and, warning, discovered traces of helium-3 in the lunar soil. Helium-3 is an isotope that could serve as fuel for future fusion reactors. Just 1 kilogram of this substance can provide the energy equivalent of 10,000 tons of coal. It's almost non-existent on Earth, but on the moon, it's found. Millions of tons of helium-3 carried there by the solar wind over billions of years. What makes helium-3 so special? Unlike other types of fusion fuel, reacting with helium-3 produces no neutron radiation, making the reactor design safe and simple. No radioactive waste, no risk of nuclear meltdown. Just clean energy in huge quantities. According to calculations by Chinese physicists, 40 tons of helium-3 corresponds to the annual energy needs of the entire United States. And on the moon, according to the most conservative estimates, there are more than 1 million tons of this isotope. That's enough for all of humanity for thousands of years. While the Americans were still fiercely debating whether to abandon the shuttle program, and the Europeans and Russians were considering missions to distant planets, the Chinese were already planning how to become the world's premier energy superpower. Chang'e 2 captured more detailed images of selected landing sites in 2010. This spacecraft could photograph the lunar surface with a resolution of up to 1 meter, enough to see the footprints of American astronauts in the lunar soil and the equipment they left behind. But more importantly, it created a detailed map of helium-3 concentrations in different areas. And in 2013, something many had overlooked happened. Chang'e 3 became the first spacecraft to softly land on the moon since 1976. For 37 years, no human had touched the lunar surface. Then, suddenly, China's lunar rover, U2, the Jade Rabbit, rolled through the gray dust. U2 weighed only 140 kilograms, but it was equipped with advanced instruments. A panoramic camera, an infrared spectrometer, a ground-penetrating radar, and an X-ray spectrometer, all of which made it possible to study the moon in previously unattainable detail. Most importantly, U2 was equipped with a radioisotope power source, allowing it to survive the moonlit night. But that was just the beginning. The real sensation came on January 3, 2019. Chang'e 4 became the first spacecraft in human history to make a soft landing on the far side of the moon. The far side of the moon isn't just a place we can't see from Earth. It's a completely unique world. There's no radio noise from our planet, and the geology there has been untouched for billions of years. This is where the von Karman crater is located, part of the vast South Pole Aitken Basin, one of the largest structures in the solar system. This basin is 2,500 kilometers in diameter and 13 kilometers deep. It was formed about 4 billion years ago by the impact of an asteroid half the size of Great Britain. The impact was so powerful that it nearly pierced the lunar crust, exposing the mantle. The technical challenge was incredibly great. There is no direct communication with Earth from the far side of the moon, as it is obscured by the moon itself. That's why, a year before the landing, the Chinese launched a special data transmission satellite called Kuqiao, Magpie Bridge. This satellite hangs at the L2 Lagrange point behind the moon, ensuring continuous communication. Kuqiao is a true engineering marvel. The 425-kilogram satellite is equipped with a 4-meter diameter parabolic antenna and can transmit data at speeds of up to 2 megabits per second. Most importantly, it is ideally positioned to ensure constant communication with both Earth and the far side of the moon. No one has achieved anything like this before the Chinese. Furthermore, Kuqiao is not just a relay. It carries a low-frequency radio telescope, enabling space exploration in regions inaccessible from Earth due to interference from our atmosphere and artificial radiation. In fact, China created the first space-based radio observatory to explore the farthest reaches of the universe. When the Chang'e 4 spacecraft landed in the von Karman crater and launched the Yutu-2 spacecraft, humanity saw the far side of the moon up close for the first time. What they found there prompted everyone to reconsider their plans for space exploration. The first discovery concerned the composition of the soil. Analysis revealed that the far side, it contained far more rare elements than expected. The concentration of titanium, iron, and rare earth elements was several times higher than on the near side. Among the samples later brought back to Earth by the Chang'e 5 rover, a new mineral was discovered, Chang'e, which contains traces of the same helium-3. Chang'e is a crystalline phosphate trapped in its lattice. This mineral was formed by solar winds on lunar basalts over billions of years. In the 50 years since the Apollo missions, no one has discovered any new minerals on the moon. The Chinese were the first to make this amazing discovery. But the most surprising news came when Yutu-2 found a strange, shiny substance in a small crater. Social media was abuzz with bizarre theories, from contact with aliens to secret military experiments. In fact, it was glass resulting from a meteorite impact. But the mere discovery showed that the moon is full of surprises. This impact glass has a unique composition, a mixture of silicon, aluminum, and other elements melted at temperatures exceeding 1,700 degrees Celsius. Analysis revealed that the impact was relatively recent, only a few million years ago. More importantly, the glass contained impurities of mantle material, confirming theories about the moon's deep structure. Then came what would become a symbol of a new era in space exploration. In addition to scientific instruments, the Chang'e 4 spacecraft brought a mini biosphere to the moon, a sealed container containing cotton seeds, potatoes, rapeseed, Arabidopsis, yeast, and fruit fly eggs. The biosphere was an aluminum cylinder, 18 centimeters high and 16 centimeters in diameter. The interior maintained a constant temperature and featured a water and air supply system, as well as a video camera to monitor the experiment. The total weight was about 3 kilograms. On January 15, 2019, Chinese scientists announced that the cotton seeds had germinated. For the first time in history, a plant had grown from Earth to the surface of another celestial body. The tiny green seedling in the gray, lifeless desert became a powerful symbol that life can exist even there. The seedling reached nearly 1 centimeter in height and had formed 2 cotyledons. Cameras recorded every stage of growth, from the swelling of the seed to the appearance of the first true leaves. The experiment demonstrated that plants can grow in lunar gravity, which is 6 times weaker than Earth's. The seedling lived for only a few days. When lunar night fell, the temperature dropped to minus 170 degrees Celsius, and the plant died. But the experiment proved that it is essentially possible to grow food on the moon, an important prerequisite for long-term bases. However, the most important discoveries concerned not biology, but geology. Using radar equipment, U-22 scanned the lunar surface to a depth of 40 meters. There, a stunning picture emerged. Beneath the far side of the moon lies a network of vast subterranean cavities, lava tubes that formed billions of years ago when the moon was geologically active. When volcanoes erupted, lava flowed across the surface like rivers. The upper layer cooled and hardened to form a crust, while lava continued to flow below, burning the tunnels. When the volcanic activity ceased, the lava dried, leaving the tunnels behind. On Earth, such tubes are found in Hawaii and Iceland, but due to the weak lunar gravitational pull, they can be gigantic here. Some are up to 1 kilometer wide and tens of kilometers long. The largest tubes discovered are about 2 kilometers wide and can be traced for more than 50 kilometers. That's larger than the entire subway system of New York or London combined. The ceiling height reaches 300 meters in some places, like a 100-story skyscraper. An entire city with a population of 1 million could easily fit inside such a tube. And now the most important thing, these volcanic tubes are ready-made shelters. Inside, there is a constant temperature of about 17 degrees Celsius. There's no radiation, no meteorites, and no significant temperature fluctuations. These are ideal conditions for building bases. 15 years ago, the Japanese space probe Selene discovered more than 200 dark holes on the moon leading downward. Now it's clear. These are the entrances to lava tubes. The Chinese were the first to realize the significance of this treasure. The American LRO orbiter confirmed the existence of these caves using gravity measurements. Where there are cavities, gravity is weaker. The anomaly map accurately matched the locations of the lava tube entrances. While NASA and private companies are still studying how to protect astronauts from radiation with heavy shielding, China has already found a ready-made solution: natural bunkers created by the moon itself. The walls of these tubes are made of basalt and are 30 to 50 meters thick, enough to block cosmic radiation better than any artificial shield. Imagine an underground city the size of several city blocks, with a constant temperature and natural protection from all the dangers of space. Under these conditions, one could create a sealed atmosphere, build living units, laboratories, and even farms for growing food. Chinese engineers have already calculated ways to seal lava tubes. Simply seal the entrances with special airlocks, and inside, the pressure and air composition could be maintained similar to those on Earth. Thanks to the low gravity, the pressure on the walls would be 6 times less than on Earth. But the Chinese have gone beyond mere research. In 2020, the Chang'e 5 spacecraft brought 5 kilograms of lunar soil back to Earth, the first samples in 44 years. Analysis confirmed that the helium-3 deposits on the moon are truly enormous. According to Chinese scientists, 1 million tons of this isotope would be enough to supply all of humanity with energy for 10,000 years. The Chang'e 5 spacecraft operated like a miniature mining facility. The spacecraft not only collected samples from the surface, but also drilled to a depth of 2 meters and analyzed soil layers of various ages. The samples turned out to be the most recent lunar rocks ever brought to Earth, only 2 billion years old. Analysis showed that the concentration of helium-3 in the lunar regolith is about 20 parts per billion. This may seem small, but with industrial mining, about 20 grams of helium-3 could be extracted from 1 ton of lunar soil. This amount would be enough to power a 10-megawatt nuclear fusion reactor for a year. In 2024, the Chang'e 6 spacecraft delivered soil samples from the far side of the moon for the first time in history. Analysis is not yet complete, but preliminary data show higher concentrations of rare elements. The far side has proven to be a treasure trove of useful minerals. In the samples taken from Chang'e 6, material from deep within the moon, brought to the surface billions of years ago by powerful asteroid impacts. Elements found almost non-existent on the surface were found: iridium, platinum, and rare earth metals. These materials are essential for modern electronics and can cost several $1,000s per gram. This explains why China is rushing to the moon, not Mars. Mars is a beautiful dream, but the journey there takes more than 9 months, with communications delays of tens of minutes, and in the event of a problem, a quick evacuation is impossible. The moon, on the other hand, is a space outpost only 3 days from Earth and possesses resources capable of changing the entire global energy system. Calculations show that delivering 1 kilogram of cargo to Mars is 50 times more expensive than delivering it to the moon. At the same time, the payload of a Mars mission is 10 times smaller, since it must carry fuel for the return journey. The journey time to Mars is limited by launch windows, which open only every 26 months. With the moon, things are completely different. You can launch at any time. The journey takes 3 days, and communication is almost instantaneous. Equipment, personnel, and supplies can be transported quickly. The moon could become a stopover for space missions. Launching from there is 20 times easier than from Earth. While Americans, Europeans, and Russians argue over budgets and dream of Mars, China is systematically implementing its plan to turn the moon into its own space station. By 2030, the Chinese want to land their astronauts, the so-called cosmonauts, on the lunar surface. This would not be a symbolic visit, but rather the beginning of the construction of a permanent base. For this purpose, a new super-heavy rocket called the Long March 10 is already under development, capable of carrying a manned spacecraft to the moon. Like the American Saturn V, the 90-meter-tall rocket will be able to carry up to 70 tons of payload to low Earth orbit. It will also be capable of transporting 25 tons of cargo to the moon, including a landing module and a 3-person crew. The Long March 10 uses environmentally friendly fuel, kerosene and liquid oxygen. The first stage is equipped with 7 engines, each with a thrust of 500 tons. The second stage has 2 engines, each with a thrust of 500 tons. 200 tons of thrust. The third stage will be powered by hydrogen and oxygen and can be reused multiple times in space. Technologies are currently being developed to 3D print structures from lunar soil. Chinese scientists have already learned how to make bricks from regolith that are stronger than concrete. A special robotic printer can build a 10-meter diameter dome in just 1 week using only lunar materials. Robots are being tested to explore lava tubes. One prototype is a 50-centimeter diameter spherical robot that can roll over uneven surfaces and even jump up to 10 meters. Inside, it contains LiDAR, cameras, and a navigation system to create 3D maps of caves. And what are the competitors doing in the meantime? NASA has promised to return to the moon by 2026 as part of the Artemis program, but these dates have already been postponed several times. The landing was originally scheduled for 2024, then postponed to 2025, and now 2026 is under discussion. There are problems with the new Space Launch System, SLS, rocket, Orion spacecraft, and lunar module. The Artemis program has cost American taxpayers $90 billion, but has yet to send an astronaut to the moon. The Space Launch System, SLS rocket, has only flown twice, both times unmanned. The launch cost exceeds $4 billion. Private companies like SpaceX are increasingly focused on Mars. Elon Musk openly states that he doesn't care about the moon. It's a boring gray rock with no atmosphere. SpaceX is developing Starship for trips to Mars, although test flights have so far ended in explosions. Blue Origin, owned by Jeff Bezos, is planning lunar missions but has yet to reliably send humans on suborbital flights. Virgin Galactic is limited to space tourism. Europeans and Japanese are mostly involved in supporting roles in American projects, and Russian space projects have long been unheard of. This leads to a paradoxical situation. While the rest of the world is discussing missions to Mars, China is quietly conquering the moon. This isn't just about national prestige, but also a tremendous strategic advantage. Whoever establishes the first helium-3 mining operation on the moon will have a virtually unlimited source of clean energy. Imagine a country that can produce electricity at a cost 100 times lower than its competitors. Imagine an industry powered by nearly free energy. Such a country would surely dominate the global economy. Those who build bases in lava tubes could use the moon as a spaceport for journeys deeper into the solar system. From the lunar surface, spacecraft could be launched to asteroids, Mars, and the moons of Jupiter. Gravity is 6 times weaker there, requiring far less fuel. Whoever controls the moon's resources will determine the rules of the game in space. The moon contains not only helium-3, but also water in polar craters, rare metals, and titanium for construction. All of this is essential for space programs. While other countries waste time with endless discussions and plans, China is already moving. Every Chang'e mission is not just a scientific experiment, but also an exploration of promising deposits and a test of technologies for future bases. Chinese engineers are already developing robots to explore the interior of lava tubes in detail. The prototype, called Daedalus, is a spherical device, 50 centimeters in diameter, equipped with a LiDAR, cameras, and an autonomous navigation system. It can roll on the surface, climb walls, and even jump in zero gravity. They are testing technologies to extract water from lunar ice. Water can be used to produce oxygen for breathing and hydrogen for rocket fuel. Chinese scientists have developed a compact reactor that can be used to ignite lunar soil. They are also studying the possibility of smelting metals from lunar ores on site. Experiments have shown that under the conditions of vacuum and microgravity, high-purity alloys difficult to obtain on Earth can be produced. These materials are worth millions of dollars per kilogram. China is also developing special jumping robots to explore craters and lava tube entrances. In the low gravity of the moon, these devices can move by jumping up to 100 meters, reaching places inaccessible to conventional spacecraft. One of these robots, the Space Locust, weighs only 12 kilograms but can jump up to 1 kilometer. It is equipped with cameras, spectrometers, and a drilling machine to collect samples. In a single day, it can survey an area the size of a small town. All this means that within 10 years, China will be the first country with a permanent lunar base, with its own energy sources and resources, and the ability to launch missions into deep space without relying on Earth. The rest of the world will watch as Chinese astronauts build cities in lava tubes, extract helium-3, and send missions to asteroids and planets, using the moon as a refueling station. This is not science fiction. It is a logical continuation of what is happening now. China is not involved in dozens of projects. It is focused on a single goal, making the moon its own. According to Chinese scientists' plans, a large international lunar research station will be operating on the moon by 2035, albeit under Chinese command and with Chinese bases. Russia has been offered very limited participation, but the Americans and their allies are not included in this project. The planned base will be located in one of the lava tubes near the moon's south pole. There, the constant solar radiation, water ice in nearby craters, and easy access to underground caves make it an ideal location for a lunar colony. The base will consist of several modules: residential, scientific, production, and power units. The residential section will accommodate up to 20 people permanently. The scientific section will house laboratories for lunar and space exploration. The production section will include facilities for processing lunar resources. The power section will be powered by helium-3 fusion reactors. What's most remarkable is that all of this is happening right before our eyes, yet most people are unaware of the scale of it. While we debate fiercely over whether Americans landed on the moon in 1969, the Chinese plan to live there within a few years. China's lunar program is not just a space project, it is a geopolitical strategy with global dimensions. Beijing is not investing tens of billions of dollars in lunar missions for scientific or prestige reasons. It is preparing to reshape the global order. Within a few years, we will likely be buying lunar energy from China. We will watch Chinese spacecraft shuttled between Earth and the moon. We will envy Chinese space technology, which will be decades ahead of everyone else. But even more disturbing is the legal ambiguity. The 1967 Outer Space Treaty prohibits the appropriation of celestial bodies by states, but it does not provide for resource extraction. The Americans passed a law in 2015 allowing private companies to own resources extracted from space. China has not yet passed a formal law on this matter, but in practice it operates on a first-come, first-served basis. Imagine the following situation. A Chinese base on the moon begins industrial-scale helium-3 mining. The Americans and Europeans demand citing international law. They demand access to resources. The Chinese respond, "You're welcome. Build your own bases next to ours." But technologically, China is already decades ahead. Space law experts are already warning of the possibility of lunar wars, not in the literal sense. No one would shoot at the moon. But the economic and technological dominance of a single country could lead to serious international conflicts. The Chinese realize this and are proceeding with extreme caution. They are offering international cooperation within the framework of their lunar base, but on their terms. Russia has already agreed. Pakistan, Saudi Arabia, and possibly Iran are expected to join the project, creating an alternative bloc of space powers led by China. And what about the traditional space leaders? The United States is trying to build a coalition through the Artemis Accords, but progress is slow. Japan, Canada, and the United Kingdom have signed the accords, but their actual contributions to the lunar program are very limited. The European Space Agency is torn between participating in the American program and maintaining its independence. Some European scientists are already collaborating with their Chinese colleagues, circumventing U.S. sanctions. Following the escalation of the conflict in Ukraine, Russia has been virtually excluded from Western space projects. The Russian Space Agency, Roscosmos, is increasingly pivoting toward China. This means that the Chinese lunar program will have direct access to Russian expertise in manned missions and heavy rockets. More importantly, China is already thinking several steps ahead. While everyone is discussing lunar bases, Chinese scientists are planning asteroid missions. From the moon, mineral-rich asteroids are easily accessible. A single small asteroid could contain trillions of dollars worth of platinum, instantly making China the richest country in the world, with an overwhelming advantage over all other nations. The Chinese Space Administration has already announced serious plans for a mission to an asteroid called 2016 HO3 by 2030. This asteroid is interesting because it orbits close to Earth and contains large quantities of rare metals. From a lunar base, this mission would become routine. There is another aspect that is rarely discussed publicly, the military aspect. While the Outer Space Treaty prohibits the deployment of weapons of mass destruction in space, it says nothing about conventional weapons. A country that controls the moon gains enormous strategic advantages. From the moon, the entire Earth can be monitored in real time. The Chinese telescope on the far side of the moon receives radio signals that Earth-based observatories cannot detect. In the future, from a lunar base, it will be possible to track the movement of all ships, aircraft, and even cars on Earth. The greatest advantage, however, is control of technology. The countries that first master helium-3 fusion will gain a decisive advantage in all areas. Cheap energy means cheap production, cheap logistics, and cheap data processing. Imagine Chinese factories running on energy 100 times cheaper than oil and gas. They could produce all kinds of goods at prices no one else can compete with. This would upend the global economy. China's lunar-powered supercomputers would outperform all other systems combined. Chinese AI will gain a massive advantage in computing power. Today, AI is key to dominance in all fields. Chinese electric vehicles, aircraft, and ships powered by hydrogen from lunar water will be cheaper and more efficient than all competitors. The Chinese space industry will be able to. Launching satellites and spacecraft is far cheaper than any other country. And it all starts now. The Chinese don't wait like others, they move. Every year brings new achievements, new discoveries, and new steps towards space supremacy. In the coming months, Chang'e 7 will be launched, a mission to the lunar South Pole to search for water ice. Chang'e 8 will follow in 2026, testing base construction techniques. In 2028, the first cargo mission will launch to deliver equipment for the future base. And in 2030, the historic landing of Chinese astronauts on the moon. But this won't be a repeat of Apollo, a few days on the surface and then a return home. This will mark the beginning of China's permanent presence on the moon. The first mission will remain at its lunar base for a month. The second will stay for 3 months. Until 2035, China plans to have rotating crews that will rotate every 6 months. A permanent base with at least 100 people is planned for construction by 2040. The moon has once again become an arena of geopolitical conflict. But unlike the space race of the 1960s, this time it's not about prestige, but about real control over resources that could determine the future of all humanity. In the 1960s, the United States and the Soviet Union competed for the right to say, "We were first." Today, the Chinese and Americans compete for the right to say, "The moon belongs to us." While the Americans argue over budgets and push back deadlines, the Chinese are methodically implementing their plans. Perhaps 20 years from now, school children will remember these years as the moment when humanity's fate in space was decided, the moment when one country staked its bets on the planet closest to us, while others dreamed of distant worlds. History shows that whoever controls the main resources sets the rules of the game. In the past, it was spices, then oil, then the internet. Tomorrow it will be helium-3 from the moon. All indications are that China will be the first country to access this unlimited energy source, and that the fate of all Earth's civilization will be controlled from the unseen far side of the moon.